Hello, stream 41. Hello. I hope I scared those who are waiting for me to start streaming. After all, it's almost a scary day, isn't it? Possibly is where you are. All right, this is stream number 41. It's going to be a shorter stream, like maybe just an hour. Going through the to-do list that I have. There are a couple things in here I might do. Also, two other things. This morning I was playing around with this. Where is it? Flame graph. Playing around with flame graph, and found a few things. Right. Found that we were doing ridiculously unperformant file position reporting or file length reporting, and now we have some file position reporting in here too. So I think it was right here. Yeah, I saw this bitstream subset. I'm like, what the hell? What the heck? And it's where we're taking the offset of a bitstream, right? This, we shouldn't be spending very much time here at all. In fact, I don't think we ever need to do a seek unless we're jumping around. So I want to fix that. So this cargo flame graph is what I used to generate that. So I want to run that again after I do some refactoring. So next test run, make sure that the tests all run. Okay, they don't. Oh, I have a comma parser. Op comma. Ah, yeah. This doesn't exist anymore. So that test can just go to the trash. To the trash with you. Yeah, that was grammar we didn't need, right? Wonder how it is we were able to run the ingestion library when the parser library wouldn't build. Oh, we have a failed test. Extra comma in front. Oh, that we fixed, right? Comma in front. If I could spell correctly. Why is my... Okay. How come I can't move around in this stupid search thing? It's not finding it. Erg. Charoot, charoot, charoot. Tej, thank you for the raid. This is going to be a short stream, though. I hope that's okay with you guys. Charoot, what's up? Rewrite an Okaimal win? 2 years from now. Probably. Unraid. Abort, quick! Abort! Like conditions are acceptable? Well, hello, all you first-time chatters from raid. I really just started, and I noticed I have a broken unit test, so I need to go fix that. But I'm also burning my code with flame graphs tonight. I want to find, like, where I'm spending too much time and, like, improve the performance a little bit. But I'm trying to find this test now, and, like, it's called extra comma, and for some reason, like, it's not finding it, and it's bothering me. Where is this test? So it's probably an expression list, right? It's probably here, and I just don't see it. Extra. Oh, it was extra space, comma. Well, of course I should have been searching for that. Actually, I got 3 tests. Which one is it? Expression list? Okay, so I have a test that fails, I think, because we don't support extra commas in front anymore. How about we turn it extra comma after? Bloop, bloop, there. So it'll be what? It'll be a passing test now? Yep, so we're gonna pass all tests. Look at all these tests that we're gonna run. Actually, I think we're gonna fail the other two now too. Yep, extra comma in front is extra comma after for all of them. Because I fixed my grammar. If you guys can hold on a little bit longer, I'll give a little intro. I swear, I'll tell you what the heck I'm doing. Just give me a minute. I want my tests to run. So these are important. Armageddon visualized because of using VS Code. We can't say the curse word, so we have to put an asterisk in front. Apparently my cat is trying to eat a blanket. ID list, invalid token. What's invalid about this? Signed integer's valid for... What the heck? Why is this a broken test? Oh, we don't expect comma anymore. Okay. Cool. Hold on. We gotta get all the tests to pass. That flame graph looks like the end of times. It is. Well, actually, what you want kind of is a flame graph where it's pretty even. It's where you have one thing that's dominant that usually is a problem. But like when it's kind of like nice and even and kind of flat like that, that means you're doing good, son. So I had like a big block in here before that didn't look right, and it was that we were always seeking to find the length of a file, and it's like, well, the file's size isn't going to change, so why don't we cache that? And then it went way down. So now I have another one here. This bitstream subset calls IO_seek a lot, and I'm like, we shouldn't be seeking in the file to find our current position. We should be able to cache that. So I need to fix that. But first, oh, they all pass. Great. So okay, ready for the intro? So, can anybody tell me what format this file is? What is it we're visualizing? Exactly. What is this that we're visualizing? No, it's not Rust. Come on. I'll give you 3 guesses. Yes, it's an image. All right. What kind of image do you think? It's a GIF image. Yes. It's a lol slide. Okay, so let's say we wanted to have a really smart hex editor that I can click on a byte and it would say, ah, yes, this is the 17th index of the global color palette. Well, my tool is designed to do just that. It's a general purpose decoder that you describe. If I put this on the side like this, this describes the format here in a custom language. It's like a mixture of structures and functions. So the image file has a structure with a header and a trailer, right? And then there's a big loop with lots of data blocks. So this means there's one header, one trailer, but many data blocks. Conditional logic controls how much we parse, right? Because we're looking ahead to see if we find the trailer yet. This image format is pretty simple. And immediately we can see things with our eyes, like the header contains a signature and a version number that we can easily see. It's GIF89A. So let's see it from the perspective of my parser. Not the flame graph, but we want to run... Yeah, this will be fine. So it does an in-order traversal of this structure along with the file and kind of tells us what every single byte means. So it does one pass, which will find all the data blocks, right? Conceivably, we want to do a second pass to do the decompression and then be able to like show the pixels and stuff like that. Haven't gotten there yet, just doing a first pass parse and really just using this format as an example. So I can program any kind of format conceivably And that's kind of what I'm looking for. I'm kind of looking for making a smart hex editor that we can program. So kind of like Wireshark can be used to study internet, network packets by adding data dissectors to understand what each of these packets means. So I could do the same thing if I was really into networking stuff. I kind of like image files and stuff like that. So I also like save game files. I like to hack the save game files so that I don't have to do the grinding, right? Not so much these days with games being online, but like back in the day, used to hex edit my save game files, give my characters billions of experience points so I didn't have to do that grind, Yes, exactly. Binary format inspector. So it goes all the way to the end of the file and says, oh, there are 61 data blocks, and there's the trailer byte. And right now it's just a command line thing, and it's going to generate like a 60,000 line output. But I can show you what that looks like, the new output. It is blah, blah, 57,000 lines, right? Yes, 57,147. It tells us what every single byte means. So if I go up to here, the byte of 4D70F is... Which one was we're talking about? This one? It's the blue element of the 72nd entry of a local color table for one of the images. I don't know which one we're in, but I guess if I scrolled around long enough, we'd probably see which one. I saw it there, but see, with so many lines, it's kind of, oh, there we go. So we're in like, each data block is going to be an image. So we're like on the 18th frame of the GIF. And each frame is like, I think it was 3/100ths of a second long, or each frame. So it's like 2 second long, lull slide. Each frame is like 3/100ths of a second, something like that. Yeah, like Pokemon save files, you got it. You want to hack your save game? Maybe give yourself a Pokemon you can't get. You might, if you could describe the format of your Pokemon save game file, you could actually find which byte that's stored in, and you can change it. And integrity checks embedded for lolcat.gif. That's another thing the tool could do. If the tool could recompute the integrity check, like the CRC or the checksum, then you could use it to hack a file and then make it look like you didn't hack it by repairing the checksum. Format spec, yeah, it's a language. So because it's a language, it means we have to have our own compiler, which has two main parts. There's the lexer and the parser. The lexer is really just recognizing the kind of tokens we have. So our reserved words, identifiers, what's an integer, what's a floating point number, and we use regular expressions. Whoa, scary regular expressions for that. Okay, the parser turns those tokens into an abstract syntax tree. It's a scary term that really just means an in-memory representation of our input. So looks like I closed the input file, so let's have to go back to it. So the in-memory version of this is basically what happens when we take away all the punctuation and we put all the words into individual slots and we connect them like in a tree. So like the GIF is the top level parent root of the tree. Next level, we have 1, 2, 3, 4 nodes. The loop has 1, 2, 3 child nodes, and the if has 1 child node. The indentation level is actually kind of a good hint about how far down the tree it is. So we do an in-order traversal of the tree. We visit header, we visit logical screen, we'll go into the loop. We visit this one, we go into the if. We might break or we might jump over it until we get out of GIF. And then by the time we get out, we had better use exactly all of the bytes. The DSL specifies something like a grammar schema for the bytecode. Exactly. In theory, you could use it for proc macros or codegen to turn the DSL code into library API to write the files also. Yeah, that would be the ultimate goal of this, is not only to parse a file, but also generate it. I'm just having fun with this because I want to exercise what I know about Rust. And I also have in the past found such tools useful. Like I said, hacking save game files. If if I want to analyze like the traffic that's going over a WebSocket, I could use this. And it's not only for byte aligned formats. If I show you the output there, here's a field that's not byte aligned. It begins in bit 6 of this byte and it's 1 byte long. I think in the GIF format, everything is always in 1 byte, but that's only because that was the choice of the designers of the format. My tool is not constrained by arbitrary barriers of bytes. The only constraint it really has is the individual field can be no longer than 64 bits, but it could span more than 1 byte. It could start in the middle of 1 byte and end in the middle of another byte. We don't care. So we remember where we started and how many bits long it is, and it's down to the bit. But yeah, most things in like traditional file formats like images, they start at a byte boundary and sometimes even a word boundary, unless it's like less than a byte long. So like one of these is like usually a bit packed, like a structure of small things. What's the case of this? These are like the flags that go in the logical screen description. So like whether or not we have a global palette, how many bits per pixel, how many entries in that palette, aspect ratio of the image. If it's 0, it means it's like some default, I think. Which index is the background color? So we don't need, actually that one is a byte long, but a lot of these you need less than a byte, and they'll do like some kind of packing for that. In a vain attempt to make the file smaller. Guess I spent an hour or 50 with the spec. It's been evolving over time. Here's what the spec looks like. It's in a language made by the Lollerpop people. So LALR pop, LALR stands for look ahead, left, right. That's a type of parser. You can look it up in Wikipedia or whatever. But it's essentially trying to match rules in a grammar and reduce them. And the input are all the tokens. So overall, we have a bunch of formats. And it's really just one format after another. So you usually have 2 rules when you have a list of things. You have the initial rule where it matches nothing, and then you just start with an empty direct dictionary here. And then you'll have itself, so it's a recursive rule. And then you'll have, after itself, you have a format. So you can imagine that these chain together, it's left associative, right? It's going from left to right, building these up each formats and just putting them into the map, right? An individual format has an identifier, optional ID identifier list, which is the arguments, left brace statements, right brace. So that is this, right? Identifier, left brace, statements, right brace. Those statements is just one or more statement. The statement could be parsing something, could be a while loop, conditionals like if else, for loop, a loop like in Rust, a special thing called a bound statement, which is really fun. Local variables, assignments, accumulation, increment, decrement, all that fun stuff. So this is in a form called Bacchus-Nor form, where you say what you're going to reduce it to, and then what data you have going to associate when you reduce it. And then you have alternate rules. So we can get a conditionals either by matching an if or by matching an else if. Makes sense, right? And whenever, so the tokens come in, they kind of come in like they're shifted in, right? Into this like stack. And then the parser is designed to, if it sees this exact pattern, it says, oh, that is a conditional. So it eats all of these tokens and spits this thing out along with this data right here by constructing it with this. So the whole thing, the whole grammar is made up of just hundreds of rules, right? Has everything in there, like all the binary expressions are in here. Like here's divide, here's left shift, here's multiply, plus and minus, comparing equality, inclusive, exclusive or, construction of maps. Yeah, everything's in there. So it's Rust and yet it's not. Everything inside these constructors are Rust, but the rules themselves are in a sort of a Rust-like grammar that the Lollerpop people came up with. This thing generates Rust code. Here's the Rust code it generates. It's so damn long that we turn off warnings on it. Yeah, it makes a 155,000 line long Rust file. 155,897 lines, and a lot of it is just going from one state to another based off of what symbol comes in. And there's shift and reduce rules. And it's just impossible to read this. I think right here is this huge, like 200 by 200 rectangular matrix of state transitions. If you want to learn more about this, I recommend the Dragon book, Compilers, Principles, Techniques, and Tools. There's now a second edition of this. Excellent book if you want to learn about how compilers work. So that's 2/3 of my tool, and it's all done. I've been making little improvements on it and little here and there bug fixes. Most of my time these days, though, is spent on the ingestion library. So it uses that compiled abstract syntax tree to break down the data. So our goal is to get bytes in, data values out. Data values look like this right here. They're all the elemental types or compositions thereof. The important question, does the second edition still have a dragon? Gosh, I hope so. Should I look and see? It would be, I think it's popular enough that we can just look up Dragon book. Probably have to say compiler, right? Dragon book compiler, and it'll probably get an image match on it. Oh yeah, here it is. Ignore the DeviantArt version of it. It looks like it still does have a dragon on it. But it's more like 1990s instead of 1970s. It's a pretty old book. So yeah, we're making compositions of these. And those go into these composite components. So at every level, from GIF to header to trailer to data block, we'll have one of these at every node on the output. So we'll know if it's an error or not. And I think in the GUI, I want to mark it like in red if the error flag is set. We remember the format that it was. We have links to its child, like its subcomponents. We remember where it was in the original bitstream, and that includes having a handle to the trait that lets us read the original bitstream. Remember where it started and how many bits long it was. What value we generated for it, which is based off of like what the bits mean. And then this is a really cool one called the vector context. That's where if something is parsed in a loop, every single loop will populate an element of its iterations vector. So, for example, the data here is not just one data, but 61 datas, right, in our lulz.gif. So every time we loop, we populate another one. Anyway, that's what I'm doing. Abstracting Rust to make your life easier? Well, this language is independent of Rust. It's just we're making the implementation in Rust. You want the MyDragon edition, the DeviantArt version? Yeah. Can you explain that bitstream implementation? Curious how you treat different sources. Sure. So the bitstream trait is basically the interface requirements of anything that can provide input to the parser. So bits means I want some bits. This is how many I want, and you get it as a U64. Offset is how many bits from the start you are, and you can do a seek by setting the offset. You can always ask for how long the bitstream is, and you can ask it if it's empty. I forget. Oh, right. I didn't actually need this one, but Rust Analyzer said, hey, you have a length. All the cool kids who have lengths have is empty. So I'm like, fine. It's easy. It's just length equals 0, right? Okay, so I have two implementations of this. We have buffered bitmap, or buffered bitstream. So we get to see the fancy lifetime annotation for that because we're borrowing a buffer somewhere, and we remember where we are in it. And here's the implementation of bits. And this is where it gets funny because this offset is in bits, but we're storing it as bytes. So we might have to pull apart some bytes. So that involves some shifting around, some masking, right? So there's some math in here. It's a little bit scary, but it works. The other stuff is easy. Offset, we just cache it, set offset, no problem. It's the length times 8 because input's in bytes. But we need to say what it is in bits. So if you stare at this long enough, you'll go crazy, or you realize how friggin' awesome it is. Making it seekable means it couldn't be used over the network. Yeah, well, this is buffered bitmap, right? So if we're reading it from the network and we need to go back, we would have to buffer it. But in general, my parser doesn't rewind. It only needs to rewind for look aheads. So we would never really need to do a set offset, even if we hadn't buffered it, unless we're moving forward. So yeah, even although technically we're required to maybe seek backwards, in reality, I hardly ever need to do that. So I also have the file, bitstream file. So here, we don't have a buffer, we have a file. And the ref cell is a little escape hatch that I'll explain in a moment. We cache up to 64 bits and we say how many bits we have. And we remember, this is the hot path, the flame graph thing taught me I should do that. So before, to get the length, we would seek to the end and get the file's position and then seek back. So realizing that that was silly to do every time we need the length, what we do now is when the file is opened, we just cache it. Then when we're asked for it down here, we just return what's cached. This will only work, of course, if the file doesn't change size while we're reading it, which would be a very uncomfortable position to be in, to be parsing a file that's changing. So we don't handle that right now. So it's a little bit more funky because I actually ported this from C++, which I wrote years ago, and it could probably be improved. But in a sense, this is the part that reads from the cache, and then when it runs out of cache, this is the part that actually reads the file. And the reason why we have to put the file in a cell and borrow it, doing the borrow check at runtime, is because when we're asked for the offset, actually, now that I think about it, we don't need to put it in a cell anymore. It was when length used to, well, an offset also. Okay, it's still here in offset. I don't cache the offset, so we have to go to the file and ask it its position. But asking for a file's position is a mutable offense, right? You need a mutable reference. Well, you don't get one with offset. The contract says no mutability, no, not mutable. Don't do it. We can do it anyway and get around the borrow checker by putting in a cell, ref cell, and doing a borrow mut on it. That's a sneaky way to get around the Rust borrow checker. You say, I promise not to mutate, pinky promise, and then you go ahead and do it anyway. Are you finding with the language? Well, it's that I was very restrictive in the interface. I said, this shouldn't mutate anything. But then for files, you do need a mutable self because it actually calls seek. So technically it's mutable, but not really because it doesn't move the actual file pointer, but it has to go through a seek, which is, supposedly does mutate the file pointer, right? So actually, I can probably fix this by caching the file position. Then the only time I really need mutable access is when I change the offset, right? Yeah, and bits is allowed to mutate self because the idea is, yeah, we probably are going to move a file pointer. If I went back and changed my interface to make offset also take a mutable pointer, I wouldn't need to put the file in a ref cell. Your temp looks different. You keep running into issues with light times in generic associated types, right? You have a generic S that you tend to change later, reduce the strictness of the bounds so they can be streamed or swapped out. You probably want to stick to your own code, but you're very curious to see if you think something horrible. Here it is, you managed to snag your attention. You snagged my attention. But I don't know if I can help you. I can take a quick look and see if maybe I can help you. I don't know. All right, so you have a trait, and you've gone into lifetimes with your associated type. Okay. Consume up to count items from the internal iterator, moving them into the buffer. So there's an internal iterator somewhere. Oh, because this is an iterator that I guess buffers another iterator. I guess that would be revealed by your new. Yes, you take an iterator, and what do you do with it? It's something that can turn into an iterator. Okay, you actually store it. Source bytes stores an iterator. Okay, but the trait doesn't require that you actually have one. Actually, yeah, why is buffered need to be iterator? Is that just because you want it to be? Because technically you didn't need anything in here that's an iterator, right? This doesn't need, you don't need to have this part. It could be both a buffered and an iterator, and that's fine, but it doesn't need, the buffer doesn't need to be an iterator because you didn't do anything here that requires iterator. But what's the problem that you ran into? Strictness of the bounds. Well, I think you have you have a self-imposed bound here that you don't need. And why do you have that there? What? This is a little bit too advanced for me, I think. You want to restrict that to a specific purpose iterator. We'll remove that once you're using a stream. Yeah, this is a little bit too advanced for me. I can admit it when I run up against something that there's no way I can give you much help other than to wonder why you're putting these bounds in here. The reason for the bounds doesn't leap out at me, other than this kind of makes sense to me. If your associated type has a lifetime in it, then I can see why the self has to be bound by that same lifetime. Otherwise, you run into a problem with holding this too long, I guess. Take a look at source cares, nevertheless. Okay. Source cares or source bytes? Have I spent too much time on the trait? Okay. Source cares. S iterator, view8 source care. Okay. So it's just a wrapper for some iterator that gives you bytes. Why is it cares then if it's byte? Shouldn't that be care? And don't you have a source bytes too? Is it because you're turning them into characters? Yes, you are. Okay. So yeah, you're taking you're taking up to 4 characters at a time, right? I don't see where it breaks out though. Is it the return? Yeah. If it can be parsed as a, yeah. If the you actually don't need the take then, right? Because you'll always, well, I guess if you get an error, but wouldn't you always get something by the time you get to 4? Abstraction over bytes a negative thing? No, it's just it was sort of weird to see that you have that's I thought it would be care, but I see what you're getting at. You're taking in bytes to produce characters. Your item, well, your item is, what do you do with the character once you get it? Size cares next. Self item. Oh, item is a character. Okay, yeah, that is your output type. I got it. I mean, I get the gist of what you're doing, but I don't see the problem you're running into. Not the Lexer is incorrect. UTF-8 character should never be more than 8 bytes. Yeah, but doesn't this guarantee that already? Why do you need to take 4? Is there a test that fails when you take out the take 4? That's a good question to ask. Nothing is done with this Lexer yet. Look at the tests. Care buffer. I mean, it looks cool. I just don't see the problem that you ran into. Is it that you're trying to solve it with these for all lifetimes things? I don't actually, I only know like a barest tiny bit about what this means. It means like that this bound should apply for any lifetime A. A is just like a placeholder saying any lifetime. For any lifetime that your iterator is bounded by that lifetime, and so is your self, which makes sense to me. This is better than a movie? Is it? Maybe if you're a nerd. I think I don't have any knowledge that you don't already have, and there's a lot of stuff in there that's beyond me, so I can only kind of guess. Yeah, sorry, I really can't help much. What time is it? 9:30. I have like another half an hour. For A in the generic, bounds assumed to be static when item slice captures lifetimes. Well, static is one kind of lifetime, right? You had to use unsafe to fix the former part, but it's all still wrong. Yeah, no problem. I wish I could help you more. All right, so yeah. Anyway, showed you some of the implementations. I'm more of an implementation person. I struggle with some of the more advanced stuff, and my implementations tend to be like not the greatest at first, but I follow a simple set of rules. First, make it work. Then once you're done, make it right, which implies that you can have something that's totally designed wrong as long as it works. You've achieved step one. And then make it fast, which means you can make something work right and be slow. Maybe it's fast enough. Don't prematurely optimize. Save optimization for the end. If you do this in reverse order, you're going to have something that it might be fast, but it's not designed well and it doesn't work. You don't want that. You want it to work right away. Then refactor. And if you need to, make it fast. And so, because I'm a simple person, if I was like more genius-like, I'd probably do all three at once. And I'm sure a lot of you in chat are able to do that. I am not. I am a simple implementer. Tonight, I was going to make sure my unit tests work, which they do now. I run cargo next test because it gives me a nice summary. Look at that, 504 tests passed. And I wanted to go to do a little bit of a performance analysis. So I was using this cargo, where is it? Cargo flame graph, right? And letting it run, and it generates a, what is it? This thing, an SVG, right? And it tells us where we're spending all of our time. And the one part I wanted to eliminate right now is this bitstream subset new, right? It goes and it grabs the offset of the bitstream, but then it goes to the seek, and I think we don't need to do that. So I believe that's in this file, bitstream file, right? So I think what's happening is a lot of the times in the code, it's going and getting the offset, right? Well, there it's going to the file and getting a stream position, right? So this is taking way too much time, and it's unnecessary because we know every time we read, we could just advance a file position. So I'm just going to introduce it now. File position. We'll remember what position we were at in the file because it's faster for us to look at our cache than to ask the file where we are, right? So we're going to initialize it to 0 because we actually seek to 0 right here. So we just have a little bit of a responsibility here, which is every time we read, so that's loop bits, right? Shouldn't that be loop bytes? I think that should be loop bytes. Yeah, this should be loop bytes. Why did I call it loop bits? Oh, probably because this is bits up here, but this is bytes here. Loop bytes. Actually, it's not even in a loop. Well, it sort of is. I think this should actually be read bytes, because it literally is the number of bytes we're about to read from the file, right? So what I should be able to do is self file position plus equals read bytes. Okay, and so I should just be able to replace this with self.read bytes. It already is a U size. Oh, it's not read bytes, it's file position. Getting the two words stuck in my head. Times 8. Don't need any parentheses, right? Cache length, because the bytes we've already read or that we haven't used yet are in the cache, and so our real position is where the file is. Go back to how many bits we have in the cache, right? So set offset. This value is what I should be putting in self dot not I don't need a let. Self.file position equals that. And then I should just be able to like not divide twice, but just reuse it there, right? Okay, now let me make sure that we still get the same parsing out of the file. I didn't break anything, right? Should get all the way to the end, which it does. So let's get the flame graph generated for this. Cool. And then reload. Okay, so let's look for hot paths. So that's blocks that are wide. So execute statement, it's okay to be wide because that's where we should be spending a lot of time, right? Okay, the log is sort of standing out to me as like, why are we spending so much time logging? And what are we doing here? It's writing to, I guess, writing to a file. Yeah, standard IO, right? So we're spending too much time logging. I think that's actually just the fault of the main program. So if I don't want to count that, what I do is I go into the main program and just not log. So that's an ingest, right? We do this log here. So what I can just do is don't register a callback for parts. There, I commented out. So it doesn't count in the flame graph. Run it again. If you change something in the test pass, it's not your fault. Yeah, well, also that bitstream file I don't have a unit test for because it's in the ingest wrapper for the library, and I don't consider it part of the stuff that's tested. If I do move it into the library, I'll feel obligated to make tests for it, but I don't have it in the library yet. I consider it like the shell. I'm not going to test the shell. What I do want to do is if I ever test anything in the libraries, I'll run this to make sure I didn't screw anything up. Okay, now this is what our flame graph looks like. Why are we spending so much time doing warnings? Oh, that's another log thing, isn't it? Yeah, I don't want to count those. Shoot. There are going to be a lot of those, though. Actually, I have a nice way to not count that stuff. In the main, I can just not instantiate the simple logger. There. Get that flame graph. Reload. Okay. We're still seeking. We're doing set offset 3 times. Yeah, we do jump through the file because right now we're skipping the compressed data blocks. And there are quite a few of them. There are 61 times like 10 of them for each image, I think. Binary operation, map, or else. What is this calling? Format inner. What's calling format? Add part. Okay, so like the construction of our path so that could be optimized a little bit more. File read. So we can make this faster by reading more bytes at a time. Right now we're only reading up to 8 bytes. So 21% of our time is actually reading the file. I don't know, these don't seem that bad really, except maybe the formatting here. And the fact that we take so long to read makes me think buffer more would help there. Okay, if it's taking 21% now, what happens if I read more bytes at once? So here, right? What if we increase this to 128? And then here, it's 16. 16. Wait, we're doing the min? Why are we doing the min? It might not matter if I increase the cache size if we're taking the lower of these two. I ought to take the lower of 16 and the number of bits left in the file, shouldn't I? Or divide by 8. The number of bytes left to read from the file. Anyway, this is shifting in U128. If read bytes is less than 16, then it's 128 minus read bytes times 8. Yeah, what if I change this to be like the lower of, the bits left would be, or the bytes left would be the file position, right? Minus the length. Divided by 8. Well, subtract them and then actually, yeah, subtract them and divide by 8. Or is file position in bytes? It's in bytes. Okay, so then I need to divide this by 8. Subtract the file position. Where's the bug? Bits. What's wrong with bits? Oh, it needs to be a 128. Oh, shoot. Yeah, we're constructing it bits as because it was really being constructed from the cache, right? Okay. U128. Why are we only reading 1 byte? That's when we set offset. That's a, well, shouldn't I do this as, again, minimum? Yeah, can I just figure this out over here? Oh, I was trying to keep it simple. Okay, well, I'll just leave that word the way it is. Let's see if that actually breaks it or not. It broke it. Actually, I don't know if it broke it. I need to put back in the logging and the output to make sure it didn't break it. Possible it just runs really fast. Nope, it broke it. Signature's all borked. Okay. Oh, this should be max, right? No. No, 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 no. I should really have done those two things in a different order, so, or one and then the other. Let's go back to 64 for a sec. 64, 64. Should make that a constant, shouldn't I? Oh, well, there was a bug. That would have been 128, I think. That might have been right there. Nope, it's still messed up. I killed it. Oh, 8 here, right? And 8. Okay, fixed it. It's fixed. So let's move to 128. Let's define a constant. Cache. Well, it's going to want me to do it in all caps, right? Cache size. That's correct. Amundo. Okay, so these 60. Well, loop bits is less than 64. That should be cache size, right? It's still constrained by in my API by 64, so doesn't really matter any, but we're gonna do it anyway. Yeah, cache size 128. Actually, there I can just say type cache type cache equals U128 and then make that cache. And then wherever I have U128 or whatever, I say cache. And this is cache size cache. Actually, that has to be U64, right? Because that's the type of the function. Blah, blah, blah. As cache size. Okay, it still works, right? So then let's comment out that and the logging and run the hot path on it. Flame graph. How do you recognize a problem in that chart? Ton of information. You just look for things that don't seem to belong. Like things that are wide that shouldn't be wide. Like execute parse statement. We do that a lot, so I expect that to be wide. But if I saw something in here like reading the file, I'd be like, we shouldn't be spending all our time reading the file. We should be spending our time doing parsing because that's our job, right? We should optimize away those things that really we shouldn't be spending CPU cycles on. Or just things that feel like they shouldn't take that long, you know? So like the reading from the file is now a lot less, right? It's only 7% instead of 20%, so it's getting better. I think this would get even better if I didn't use a single variable for the cache, like if I actually used an array. And we read like a whole like 1024 or 2048 at a time. But maybe it's good enough. So I'm curious now. It's 7.89% to do read exact. What happens if I just switch it now? Now that I can switch it to, I can easily switch it to 64 here. How much does it change it? Will it double or just increase a little bit? It actually went down. Read exact is now 5%, but it's only 2 samples. I think our code is running so fast now, it's hard to actually get a lot of precision in the numbers. So we get 20 samples. What we kind of want is you want a lot of samples. Only 39 samples is not that great. See, if I ran it again and get another 39 samples, This probably changes the shape a lot just simply because of the sampling. You see now the wherever it is, the I can't even see them because they're so small. The reading, I don't even see where it's done anymore because it's so small. Our code is so fast that it makes me think like we should try to give it a harder job, and we'll get more useful information from a from a harder parsing job. Bookmark Thorium browser. Thorium browser. You think I shouldn't use Chromium? Thorium browser. Fastest browser on Earth. Chromium fork for Linux. Huh. And I'm using Chromium. It's a Chromium fork. I do like element names, by the way. Cool. Bookmarked in my brain now. I think I'm cool with this, and I like that I made this type like a little bit more programmable. And there was that weird thing in here where when we're reading the file, it was only reading like as many as needed and not like this should try to fill the cache. It should be aggressive about filling the cache, right? So actually there's a hard-coded number in there we don't want. We want cache size divided by 8 in there. So that should not break anything. Yeah, we're cool with that. All right. Yeah, we want to try to read up to fill the whole cache, right? Wait. That again should be divided by 8. We're reading too much memory. This is bits. Bytes, bits, bits. Bytes, bytes. Okay. Let's go back to 128 to make sure it still works. Yeah, okay. I guess I should keep it at 128, right? Until I improve it to use something other than a single value for the cache. Like it should use memory, like actual array of memory, not a single number. To use a array though would make this a little bit more complicated. We couldn't just like shift the cache and take the cache and assign it into the bits and undo all that stuff. We'd have to shift in parts at a time. Actually, you know what? Actually, it would still be okay because the way it would work is we're still limited to a U64, right? So we would just read multiple cache values at a time, and when we're done with one, we would move on to the next. Actually, I can almost see how I'd implement that now. In here, we would just read multiple cache values, and in here, we would just consume the next cache value and then move on to the next. So it wouldn't be what if it's greater than. Yeah, this would not be cache length. It would be like cache length mod cache size. It would tell us how many more bits in the frontmost cache value we could take out, and then that's how many we would do in that loop. And we would do at most 128 bits every loop, but we'd still only be reading from memory, and we wouldn't fall into the reading bytes. Gonna borrow that bit packing cache trick for yourself? Cool, no problem. Yeah, I don't like that. We're only reading 1 byte to start with. It's that I'm taking a lazy approach. I'm saying wherever we offset to, just read in the rest of just read in that byte, and then don't bother figuring out how many more we could have read. Yeah, and I need to end the stream soon. So before I go, I want to do one thing, one to-do list item. It'd be fun if I could do one that involves changing the compiler. Maybe this, adding, well, this one's easy though. A warning instead of an error. This is too hard. To consider having a bot stuff that was just stream related, they're not related to the compiler at all. This might be interesting. Consider allowing locals to be marked in some way to be saved as parts of a component. Oh, there was another one that was similar to that. It was like marking arguments to be local only. Or was it? Consider syntax for excluding an argument from the component set of exposed parts. Yeah, because that would not actually not be too hard, right? And it would make it a little bit interesting because then the arguments aren't just as string identifiers; they're also like there's a flag associated with each one. Hey, let's try this one. So a syntax for that. I keep opening the auto-generated one, and I'm meaning to open the lollipop file. Okay, so that's in op ID list, right? Yes. So let's give it a better name. This is optional formal. Let's just call it formal parameters, formal arguments. Let me just call it arguments because that's the name I chose there anyway. It was op ID list, right? Yeah, arguments. So right now it is an ID list, but let's call it, because ID list is used in multiple places, right? Nope, it's not. Oh, my Roomba just made a distress call. Hold on. What happened with the Roomba? Someone cruelly blocked Roomba's escape path to get home. ID list. This should be like arguments, and the other one's op arguments. Op arguments. Because then I can call this one arguments. I can call them all arguments. Okay, so it's not going to be a vector of strings anymore. It's going to be a vector of argument. So we're inventing something new. So there's a string but there's also an argument, ID. So that's what it'll start with. Let's make this actually just work as is first. Okay, and then in the AST library, I need to invent this. So AST argument .rs. And the lib mod argument. Pub use argument argument. Argument. And then we just have an ID, which is a string for now. Okay, and then to make sure that the parser actually builds. It doesn't because the grammar has a problem. Right, because so for format it has to have arguments, not strings. So function, wrong place. In the AST, format as argument. Okay. Here we go, we're chasing errors now. So format arguments is an argument, right? So add part needs to take an argument. This is actually consumed, right? No, it's okay, it's by reference. So it's not a name anymore, it's argument. So argument ID. Actually, I can call it name by doing it this way. Let name equals argument.id. If I borrow it. Yep. Local statement is actually no, this one shouldn't. Oh shoot. This one can't take, or we reuse this, so this has to be name. Okay, my bad. It's here that we have to do formal.id borrow. Argument ID is that. Yeah, we gotta fix the things. Oh, I changed the name of this, didn't I? Okay, change the name of this argument. Arguments, right? This is actually more changes than I bargained for. So this has got to be like an argument also. Two arguments up there. there. Okay. Not too bad. Although for that vector, I wish that this did the formatting for me, but it doesn't. So I have to do that. File not found. It should be found now if I hit save. Okay. It doesn't know what argument is. Now it does. I need to change op ID list. It's op arguments. ID list is arguments. Argument. Use AST argument. Okay. So here I need an argument, right? Project isn't available on GitHub yet? Nope, because of job rule 3. Save the tests. Argument ID. Sure got a lot of warnings. I have another error too. Oh, the grammar's wrong. Okay, that's in grammar, not this one. I know where this is. Thought I did. I thought I knew where to look. Right here. This should be that. Cargo build. So that regenerates the Rust code for this lollipop file, and hopefully it builds now. The objective was not to actually break anything there, but to introduce a structure that now I can add a field to. So we still have argument can't be formatted with the we have to have a formatter. Or I can just cheat and say it's oh, I can't because I'm using a macro. Okay, well we'll make a formatter for it. We have another error? No, that's that error. Okay, do I have a formatter for any of these? I do. Like I have a display for, okay, so we can have a display trait for this implement display, which is that for argument. Save and come on. I know you can do it. Really? It can't do it? Oh, wrong trait. That's not a trait. That one. There we go. So let's just do a write F. Oh, it's F and then self. Can't put self in there. Cause infinite recursion. Oh, sorry. Self.id, which I can't do here. So I take it out and do a comma. All right, so that should fix the error that I had. I guess we don't use that there. Okay. Cargo next. Hopefully I didn't break anything by introducing a structure for an argument. Cool. We didn't break anything. But now I have this nice structure I can put stuff into. So the goal would be to, in addition to an ID, have like a flag about whether or not it should be persistent. Okay. And then I have the idea that I want to put a plus there if I want it to be persistent. So that would be like this. We'd have another thing there that would say like if, well, actually I can do it this way. Do question mark semicolon. I can say if self.persist f.write string plus. Then I have to do this because we have to, all paths have to lead to okay. Okay. Right? So turn around and put that on the grammar would be that we could have an optional plus. And I have that in here somewhere, don't I? Okay, I almost have it. But I combined it with something else, so now I gotta make another rule for this. So this is like optional plus. And that gives me a Boolean, right? So let's make empty go to false and a plus go to true. And then, so we'll just have persist op plus. And then we just put persist in here. So another thing I can do is I can just call that ID and then I don't need this colon S anymore. I think that's a super idea. So we'll also put a persist there. Hopefully this doesn't make the grammar ambiguous. If it makes the grammar ambiguous, we're going to get a ton of errors right here. Cool, it worked. So then I should be able to like test this out in a formats test. Format test? Or why do I have a format and a formats? Oh, this is at the grammar level. I want a format at the ingestion level. Well, actually, no, I do want it at the format level. Why does this still say it's an error? I think I need to rerun the... Oh, because it is an error. Right. Everywhere we have argument, we have to have a persist now. Persist is in... It's going to be false for all the ones that we've made so far. So there, there, and there. And there. One error. Missing a persist... Oh, two errors. There. There. Is that it? So I should just run my unit test, because then it would have told me that I broke it. Right? Run. Okay, I broke the too many tokens. How is the too many token test broken? Oh, did I use a plus for that? I probably did. I probably put a plus in there. Yeah, so that's actually valid now. So I need to put like a minus to fix that test. And actually this is going to change. It's going to say either comma or a plus, right? Yep, comma or plus. Plus is now acceptable there. Slow compiler, slow. Rust, compilers are slow. That's still wrong. Oh, unrecognized token minus. Yeah, I changed it. Compile. You can do it. ARP renminxing is broken. Oh, because plus is now a legit next token. And oh, I think I misspelled unexpected there. You expected? You didn't expect it. Wow, there's actually 3 misspellings. Token inside list. So this is where I did break it, right? So yeah, it's plus is also acceptable there. But let's also finish the spelling here and here while we're at it. That's a copy paste bug or keyboard fail, however you want to think about it. Almost done, and I can go to bed. Unexpected token inside list. Token inside list? Oh, yeah, that's not an invalid token. Let's change that to minus. Minus. Yes. Building. And we passed all the tests. Okay, so let's add a test for the thing I'm actually wanting to do. I guess arguments is a fine place. So we have 2 arguments, one identifier. Actually, all I really need to do is like add a plus. And then that marks it as a persist. Right? I don't know why it said that. Cool. So now to actually do something with it. So a test for that would be in like the ingestion format. Simple format, right? Okay, that didn't have arguments. Do I have one with arguments? Like part maybe has one with arguments? I don't see. Well, here's one with arguments. What kind of test do I have here? Function maybe? Well, I don't know why I call it simple format. Why don't we just call it format? Oh, because these are simple formats. That's why. Yeah. Okay. It is a simple format. Okay, so it's not the non-simple formats. I guess I don't really have a place that fits, and part is too big. What if I just make a new one called format? Oh, I didn't mean to do that. New test file called format. And tests will have a mod format. Let's copy from something else like, I think break was a nice one because it's really small and has the template for a test in it. Okay, so use super, all that stuff. So formats is foo. Let's have a bar that has 2 arguments, x, which is public and or persistent, and y, which is not. I feel like that it should be the opposite, maybe. And I should have made that a minus, which means, or like a minus in front, which means that like it should not persist. Maybe by default arguments should persist, because that's been the default. But then I'll break all my tests. Oh, we'll just make this work, and then I'll change it tomorrow. So the way this should work is, it doesn't really matter what I do here, right? So I can just do nothing. And I can just say bar 4269. So what this should do is foo should have a bar which has an X in it, but not a Y. So assert equal data value unsigned. Why is it not helping me? Oh, because I don't have this? Yes. Unsigned integer 42 for foo dot keyed children. Oh, I didn't call it foo. I called it. Why is it dropped? Let foo equal foo dot keyed children dot get x unwrap value. Okay, I can close this so we can see it better. Okay, and then, but y should not exist. So assert that when we get a y, that it's none. Actually, how about we just turn this around, and right now it's called persist, but we're going to turn it into a flag that actually makes the value not be kept. So by default now, this will fail because it's actually kept, and it'll be 69. Oh, this don't care about. Get rid of that. It's leftover. How does Rust format mess up there? Also, what's the reason for the last rule? Rust format mess is up in the, where was it? Where I have test case. Because it's a macro that's kind of complicated. So like, wherever I have to do like complex indentation. Yeah, like if I hit it doesn't know how to reformat this. I think because this is a macro and this is too complex for it to format. And the reason for this rule is sometimes I'm going to want to have parameters not appear in the final data composition. They're like private parameters. And I thought this would be easy to do tonight because all I really need to do is adjust to add a flag to every formal argument. And then when we're putting the value in the output, we can just mark it as local if it has that flag. And then at the end, everything marked local is removed. You mean, why is there an R hash in format RS? Right there, just so that this can be a raw string. If I don't do that, then I might have like a backslash or something, and then that gets interpreted as a new line. But if I have a raw in there, I don't have to worry about it. Now it's a literal backslash and an n. It's when I don't want escape characters interpreted. That's really, you really meant the bots message. So I totally misinterpreted both parts of your question. Sorry. Which rule? What's the reason that I not participate in open source projects? Well, it's just their employment agreement is that you have to get okayed for that sort of thing. And the okay process is like really long and cumbersome and takes years. Twitch searches and makes you lazy with questions. Oh, that's fine. Why do you need Rust format skip? Oh, right here? Yeah, watch what happens if I don't have that. Okay, this one's okay. Maybe when it's not a raw string. No, this one's okay. It was on some of these it's reformatting it. And because it doesn't understand my language, it thinks it's Rust. Like if I remove that and I outdent that. Okay, it's not doing it now. Maybe it's because it's a raw string. Yeah, I don't know why. At some point it was like interfering with the string. And it was like formatting the inside of that. It's not doing it now though, so maybe I don't need that. Maybe I delete that. Because it doesn't seem like we need it now. Just add percents until you're good. That's true. I should give you a point for challenging me on that, and we find out we don't actually need it. And I don't remember why I needed it in the first place. Have a useless internet point. You have one now, one total. We don't need any bytes here either, right? Anyway, this should fail the way I want it to fail. Break in the correct way. Why is it getting none for X? Oh, because we're supposed to look at foo.bar. Bar equal foo.keyChildren.get bar dot unwrap, and these should be bar. Okay, yeah, assertion failed that get y is none. So y is appearing in the list of parts of bar. So I don't want it to when I have this flag attached to it. It's called persist, but I really want it to be called like don't persist or local. Actually, I want to call it local. And I don't want it to be a plus. I want it to be minus. I want to move it in the front. But I'll make all those adjustments tomorrow. I just want to actually get this working and then go to bed. So where this is done is in the part, right? So statement. Execute part statement, I think. Parse statement. I think it's ingest composite that it must be in here because it gets the arguments. Populate composite arguments. Here we go. So it goes through the arguments somewhere. Yeah, right here. Yeah, exactly. When it adds the part. I think what we want to do is when we add it, it's actually going in and, oh, well, actually, we don't need to modify it after we put it in. We just want to do an additional, right? So if formal dot persist, do we want to do self dot locals dot, oh, it's a hash map, right? And just insert formal dot id dot clone. That should make this pass without breaking anything else. Cool. So now on the way out, bar remembers what X is, but it doesn't remember what Y is because we put a marker next to it. Cool. Actually, I wonder if I could just, I shouldn't do it. I shouldn't stay up any later, but I really wanted to do it this way now that I think about it. I wanted it to be in front and I wanted it to be a minus, and I don't want it to call it persist. The persist thing is easy to change, right? We just go to where it's declared and we just rename it using the, we call it local. And then I can fix this part and just put a minus in front, right? And then persist is still in the grammar, so I need to fix that here. And that's optional minus, right? So that's a minus. Okay, and then it's going to break a bunch of the tests because a lot of those tests, what happened to my shell? I must have killed it. A lot of those tests like use minus instead of plus, and yeah, this is going to break a bunch of things, but I kind of want to fix it tonight before I go to bed. Ever put your code in ChatGPT and say make it simpler, more efficient? No, because I don't believe that ChatGPT would do a good job with that. I could be wrong or biased, but I think of ChatGPT as taking all of the things that it ingested from the internet, including a lot of code samples, and then finding all the context of it all, and then categorizing everything. And then when you ask it to give it code, it goes and it selects and it massages, and so you're going to get only as good as the internet can give you. So maybe it can do a good job, but maybe it can do some mistakes. I don't know. If someone like you writes good code and makes it learn, see, but I don't write good code. But just kidding. It'd also take the fun out of it. So why would I do something that takes the fun out of what I'm doing? Like, sure, maybe it can do it, but I have fun doing it myself, so it's not something though that I would end up doing, right? Why is it test break? Did I just call it test break? I think I did. I called it test break. Like it, yeah, I forgot to rename the test. It was here, right? Probably called it test break by accident. Yep. So test format ignore argument or local argument. So yeah. Actually, that's what it should do. Why did that break? Oh, I needed to move it in front, right? Front of the ID. Hopefully it doesn't make the grammar ambiguous. It remembers, but it's not actually smart. My man ChatGPT is for React Andes. I like ChatGPT as a search engine replacement because it has the information in there, and really I just wanted to spit out what it remembers about something. Like I'll ask it in Rust or on Linux, how do you install what was the other thing I did yesterday? How do I install perf? How do I install perf, right? And it's like you need Linux tools, you need Linux tools common, and it was spot on, right? It's because somewhere on the internet it said to install perf, you need these things. That's what we want from search engines, right? Find the information quickly, to figure out what we're asking for, locate the information, and spit it back out. Invalid token, right? Yeah, I remember hitting these. Like, these are all wrong now. Wait, what? That one's okay, right? Yeah, I think that one should be okay. No, that's not okay now? Hold on. Oh, because it might have expected a minus. Minus. Right there. with the comma there. Oh, and an actually this one should be okay. Too many tokens under arguments. Yeah, so this is minus now, right? And we have to say plus. Actually, it's not going to expect a minus anymore because we didn't put it in front. Two identifiers. Yeah, this needs to be token minus here. There we go. Yeah, it is a pretty good search engine. It's extension to your hippocampus. Yeah. I wonder if that's where we're heading towards, that we all get an AI brain implant to kind of like automate some of the things that we find tedious and boring. Or just to like expand our capabilities, right? I already do that with glasses. Without these glasses, I wouldn't be able to see. But now I can see because I have this adaptation. Why not have a brain adaptation that searches the internet for me? Too many tokens. How is that failing? Oh, unrecognized token plus. Your wife would automate you away. Yeah. How are you doing, Togglebit? I'm staying up 39 minutes too long now. It's official. Thought this would be an easy change to my grammar. It turns out to not be. Unexpected. We're in optional arguments, right? Yeah, we should expect not a plus anymore. Unexpected token inside list. That's this one. Yeah, we don't expect that's a plus and remove this. I'm doing well, although I'm staying up too late and I'm not getting enough sleep because I'm just having too much fun on these projects. Look at that, we passed all our tests. So I just added a syntax to my language so that I can do something like this, where I can say, bar has arguments x and y, but I don't want it to remember what value y had, because maybe it's like something that I don't care about in the final output. So in the final output, we get a foo and we get a bar, and bar has an x, but it doesn't have a y anymore because we marked y as an ignore or a local. Also, that being a local, it also behaves as if we had like a local variable like this, or express local like that. So I was just thinking I can do that that was on my to-do list as a little tweak I can do, and I have enough time to do it. And I spent 40 more minutes than I thought I would to do that. So that was this one. And I'm done with that now. It only took me 24 days to do it. Could use raw strings instead of escaping those quotes. Oh, right here. Yeah. What would be cool is if I could have a syntax to get rid of the two strings. Like, what if we had a capital S or something, and that meant allocate a string or something? Anyway, I think it's time for me to hit the hay. And I'll be back in the morning to do about an hour and a half's worth of more work. I could make a macro, yeah. What do you hate about Rust? I don't hate anything about Rust, but I guess what gets me sort of irritated. One of the very first things I learned about Rust, which was that the default integer type is I32. Actually, I don't even use it, but like, you know how like you can't say like just int, you have to say like I32, and you can maybe say iSize, but really that's just the same as saying like size t in C++, right? It's the fact that there's no equivalent to int in Rust. You have to be opinionated about the length. That irks me. There are a lot of places in the code where I end up using usize or iSize because I hate saying exactly how many bits it should be. I would like it to be whatever's convenient for the machine I'm building it for. So if the most performant type is 32 bits, I want it to be 32 bits. If it's 64, I want it to be 64. But if I were to use 32 and then I run it on a machine that's more performant with 64 bits or vice versa, like if the only reason I had to pick 32 is because I had to pick something, I think that's lame. I should be able to just say UI or uint and let it figure out the most appropriate type for the machine I'm on. That's one of the very few things I don't like about Rust. Why isn't int iSize? Because int or iSize is equivalent to well, that's equivalent to taking a size t value and casting it to like you take some value 42 and you cast it to I don't know. It'd be like an iSize t, right? Really, it's usize matches size t in C++, right? But then what is int, right? There is no type in Rust for int. It's not iSize because that's really just a signed version of usize, which is a size t, which is it's a distinctly different type from unsigned int, right? Size t has a connotation, and that is it is as wide as your memory bus. The number of bits in your pointer, that's the number of bits in the size t. Int is different. Usually it's implementation defined, but I think the intention is it is a flexible sized integer where the implementation gets to pick the most convenient size. We don't have that in Rust, and it bugs me. It bugs me a little bit. I don't like the fact that it combined the concepts of int and size t. That bugs me. You asked me what I don't, well, not you, but XLO Milo asked me what I hate about Rust, and I don't say I would hate it, but I just don't like that. Oh, no, we're missing the whole type. It's that we've combined two concepts into one. I don't like doing that. I like separation of concern. I like having one type that's the meant for memory lengths, like sizes, and the another one that's just a flexible sized integer that matches whatever the implementation finds convenient. Another indication that there should be such a type is when you get diagnostics from the Rust compiler, or if you do the key combination that gives you these I'm not seeing it here, but these inlay hints. Sometimes when there's an error or it doesn't know, but the exact type, but it knows it's an integer, it'll say in curly braces integer, and I'm like, aha, there's a spot where like the unsized integer, so to speak, would fit. I want int specifically because it's not dependent on the width of register. Exactly. I want it to pick the size based off of what is most appropriate for the machine. Meaning like if I don't need more than 32 bits and it could do 64, but it's slower, I want us to do 32. Or maybe the other way around. Maybe 64 is faster than 32. And I didn't know when I wrote my program that we would have 64-bit machines, so I wanted to like upgrade it automatically. With Rust, once you call it a U32, you're stuck with U32 forever unless you go change your code. That can never become anything other than 32 bits. Even if 20 years from now we're all on 512-bit machines, someone's going to have to go and change all the U32s to U512s to make it compile again, because we've gotten rid of 32-bit values from the target architecture, or there'll be some kind of weird hack in the compiler to upgrade automatically. And yeah, I just don't like that. Why do we need to force it to be exactly 32 bits at the site where I'm using it if I don't care? I should be able to say, all I care about is that it's an integer and it doesn't have a sign. Make it whatever size is appropriate. Especially in a language like Rust, where we can omit the types almost universally. I have very few types here, right? In the actual implementation, very few types. So when I have them, I think they should have importance in the context. And the 32 in U32 is very rarely important. Very rarely. And like, why is it 32? It's an artifact of powers of 2 being convenient in computers. So yeah, everything else about Rust I'm generally fine with. What else do I not like about Rust? Maybe that the way that, this isn't the language itself, but the way that it's taught, its lifetimes and the borrow checker are taught in a weird way where most people like misunderstand it at first, and then it seems hard, but really it's not as hard as it seems. It's just not taught well. So maybe the lack of really good teaching material about Rust, making the language seem hard when it's not as hard as it could be, as it could seem to newcomers. Okay, I gotta go, because if I don't go to sleep now, I'm gonna be really unhappy tomorrow. Wait, there's a wall text. You hate the way that they merge features into stable too quickly without worrying about if it's complete? Oh, yeah, I can understand that. What's Polonius? Impl and return and argument positions. Yeah. Yeah, and they've made some mistakes that now they have to live with. Right. Well, not everyone's perfect. Should we raid Koopa Man because he raided me before? He's making a puzzle game in Rust. Let's do it. He's not in the top 5. I'll just have to type his name. Here we go. Yeah, later, Nightshade Dude and everyone else. I'll be back in about 8 hours from now, after I sleep. So, see you then. Bye.